Perfect, perfect. So we're going to start off here, and then we're going to get into breaking off into groups, where you guys are going to be working a lab, where you and your partner are going to pick a metal rod, and you're going to be doing some measuring with it. But before we can get to that, I need to make sure that we know how to read our scientific tools that we're going to be using throughout the year. Now, there's two numbers that there's three things you're going to be recording every time you measure something in this class. You're going to record all known digits. You're going to give me an estimated digit, and you're going to give me the unit. Because once again, if you give me a number and there's nothing attached to that number, I don't know what that number means. The unit tells me what that number means. So there's three things. So first step, we're going to write down all the known digits. So that's what the tool tells me. So what the tool tells me, we're going to be using both, We're going to be using both scales and also volume graduated cylinders for a lot of stuff that we're going to do. So the first thing, so if I'm looking here, and my cylinder here. Remember, when I am measuring fluids in a graduated cylinder, I always want to go to the bottom of the meniscus. That gives me the true amount of fluid in the container. And in my example, I'm somewhere between 4.1 and 4.2. So my known digit is the 4.1. Does that make sense? Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines. 5 minus 4. So 10 over 1. Each one of those lines represents 1 milliliter. So first thing I'm going to do is I'm going to write down the known digit, 4.1. Second thing I got to do is I need to write down the estimated digit. Now, your estimated digit is always going to be either 0 or 5 in this classroom. So, if it's 0, I expect the meniscus to be sitting on the line. If it's anything past the line, it's 5. Now, you might be going, well, Mr. Watts, I can kind of see that doesn't look quite halfway up up between 1 and 2. I know. It's an estimated digit. What you're telling me is that it didn't quite fit on that line. You give me the known digit and your estimated digit, which is either 0 or 5. I don't want to see any other number right now in your estimated digit spot except for 0 or 5. What two digits are your estimated digit? What are your two choices for your estimated digit, guys? 0 or 5. I need everyone to say it with me so I know that we understand. Estimate is 0 or 5. Hit me one more time. Hit me one more time with a little bit of life in it. All right, one more time. We're trying to wake the dead now, guys. Man. Did I walk into a zombie movie? 0 or 5. Oh. Y'all need to get some more life in y'all. Y'all too young to be sounding this tired first thing in the morning. So, what's going to be my estimated digit here? 4.1 what? Hey, so good to see you. Got a pass for me, girl? They didn't give you a pass. All right. And lady, I'm going to find your spot. Let's just put you right next to Namor for the time being. Yeah. That's right. You also want to before you let's grab one of these papers, and I want to see your phone in my little card in front. Well, I'm gonna let you guys know. If I see you staring down, looking like you're looking at a phone, after the day, I just ring security, and you can have a conversation with them. And let me tell you something. Like Dr. Chapchak said, in the little stuff that she did yesterday, first time she take it, it ain't for the end of the period, it's all day. Second time it go down there, whether it was down there yesterday during 1G and came back to her during 2B the next day, it sits there until the parents come get it. Do yourself a favor if you magically find your phone in a purse, in your bag, in your pocket, in your hand right now. It finds its way to the little card up here. But 4.1, what's my estimated digit going to be, guys? Am I going to choose 0 or 5? What's up? Got an option for 0, and I got an option, what'd you say? 5. Remember, if it's 0, I expect the meniscus here to be sitting on that line. Is it sitting on the line? No. So it's not going to be 0. It's going to be the 5. 4.15. And the unit for any graduated cylinder that we are going to use for the next 10 months is always going to be milliliters. So I'd write this number, 4.15 milliliters. If my meniscus was, say, I have something like this. So here, I see my meniscus is sitting on the 5, right? So it'll be 5.00 milliliters. If it's on the line, then my estimated digit is going to be the 0. If it's anything past the line, it could be all the way up to the top, just below, right? That's still going to be a 5. It can be all the way right here. It's going to be a 5. The estimated digit is always either 0 or 5. I'm very big stickler about that early on because I want you guys to get comfortable with writing the estimated digit. Okay? A little bit further down the road, we can add a little nuance into it. But right now, I am very stuck on 0 or 5 for the estimated digit. So, let us go ahead and scroll down a little bit because we're also going to be using scales. Now, a lot of times when you go to the doctor's office, they just have you stand on a digital scale nowadays, right? But back in the day, they had these sliding scales that we're going to be using today because it is an SOL, excuse me, it is a SOL standard that you guys are able to read the sliding scales. Now, here's the good news. Any type of sliding scale that we come across in chemistry is going to be, the unit is going to be G, which is short. G is short for grams. And to make life even easier, when we see these 3 beam scales, you know what we're going to do with all the numbers? We're just going to add them up. So, out of my beams here, what's my first number that I see? What's in this beam right here? 50. Why? Because my little mark here is set for 50. All right. 50. What's the next line say? 100. Okay. What's the last line say? You might want to count them out on your paper. 3.7. 3.7. Count. 1, 2, 3, 4, 5, 6, 7. 3.7. First thing I want to do is I want to write down all my known digits. 3.7. Now I can pull out a handy dandy calculator and add all this up, or I can just do this little bit of math in my head. There's a 7.0 plus 0 plus 3 is 3. 5, 3. These are my known digits, right? what's going to be my estimated digit? Now, when it comes to the scale, when I'm making my estimated digit, I'm only looking at the smallest one. Is that going to be a 0 or a 5? You sure? Looks pretty on it for my place. One, 5, 3.7. These are my known. 0 is my estimate, and my unit is grams. Everybody see how we got it? On the next page is another scale for you. I want you to try. Now remember, all my units here are grams. Because any scale that I have comes in grams. I want you to try to write out your what you believe are the known digits, right? Estimated digit, and the unit. Ivana, we're on the next page, or on back here. We're going to spend some more time with it. So don't think that you're totally We'll walk everybody through it. All right. Let's walk us all through this one. Because the nice thing about the known digits is that all I got to do is read what I got here. So my top bar. What's my top bar? What is it, guys? What's the top bar say? 100. All right. So I got 100, right? All right. What's the next bar tell me? 20. What's the next bar tell me? 8. What's the next bar tell me? So I got 0.1, 0.1, 0.2, right? I'm going to get there in a second. I'm going to record 0.1 or 0.2 right here. 1 because that's what my scale tells me, right? Now I got to count because these are also known digits, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 ticks in between 0.1 and 0.2. So what number is associated with each one of these little ticks? If this is 0.1, what's this line going to be? 0.1 what? 0.11. What's the next tick going to be? 0.12. What's the next tick going to be? What's the third line represent then? 0.1 what? 3. All the way down to my last tick, which is 0.19. These are my known digits. Now, I look at my smallest scale, and I see that it's not sitting on the 0.9 mark, right? 0.19 mark, right? So what number is going to be my estimated digit? 0 or 5? 5. My unit is grams. 591.0 plus 0 plus 8 plus 0 is 8. 0 plus 2 is 2. 1 plus nothing is 1 grams. Your known values, you have to tell me all the known values based off the tool you're using. The last one is your estimated digit, either a 0 or a 5. And lastly, you gotta add the grams. Does that make sense how we got those? Because these are the things that we're going to be using on the quiz in, today's what, the 15th? 2 weeks. If you're not feeling comfortable, I can get some more for us. We will be sitting together in advisory on Monday. And what we could do is that we can just run a bunch of these. Sometimes the best way to figure it out is just to run them until we're tired. Coach Copeland may know a little bit about that. We're going to run it till we get it right. Repetition is a great way to solve problems. Not a punishment, guys, because you're going to have to be able to do it. So we're not getting it today. We're going to be working on it on Monday. One cylinder over here. Graduate cylinder. I told you it's marked for milliliters. What is the known digit off my graduate cylinder here? For number 1, what's our known digits? 20's here. Well, my liquid goes up higher, right? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ticks between 20 and 30. So each one of those ticks represents 1 milliliter. So 21, 22, 23, 24. So my known digit is 24. I don't see any decimals there, so point. What's going to be my estimated digit here? 0. 24.0. What's the unit for our graduated cylinders? Milliliters. All right, let's look at number 2. 1, 2, 3. What are my known digits? This one? 2. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ticks between 3 and 2. So what does that mean? What does each one of these lines represent? 0.1. 2.1. 2.2. So what's it? What's my known digits? 2.6. What's my unknown digit? My estimated digit? 5. There you go. Unit? ml. Perfect. Milliliters. These are things that we're going to be using today to determine the density of one of our rods. What I'd like for you guys to do, I want you to grab your unknown, we'll call it CER, claim evidence reasoning, identifying an unknown element. I want you to pick somebody in this room that you can work with. Once you are paired up with that person, I need you to stand up and step to the side, the perimeter of the classroom with that person. So everybody got their paper in hand? Everybody got their paper in hand, gang? We're going to try this one more time. It's a yes or no answer. Does everyone have their paper in hand, gang? Yes. Perfect. Everyone on your feet. Get on up. We got work to do. I got to go find me a lab mate. Gonna walk on down because all the stuff we're using is on the perimeter of the class. Ain't nobody gonna be sitting there doing nothing on their ass. Let's go, let's go. Come on, come on. Let's go, let's go. Oh yeah, all right. Y'all need to get livelier, man. Come on now, jeez. Partners? 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 Who's your partner? Get close to him. Gentlemen partners? Perfect. Gentlemen partners? Gentlemen partners? Group partners? Ronald, congratulations, you're with Keith. All right, gang. So we got paper in hand. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I don't have enough scales for everyone to have their own scale. So that means, gang, we're going to have to share. Woo, man, it's crazy. Now, in my little bucket here, I got a bunch of different rods of different metal types and different sizes. I'd like for one person on the team to pick one of the rods. Pick one, guys. Pick one, guys. Pick one. Ooh, pick one. Pick one. All right, pick one, guys. All right. I'd like for you to find a scale. There are 1, 2, 3, 4, 6 scales I have out. Now 9 groups, so that means that some groups are going to have to team up. I'd like for you and your partner to go stand in front of the scale. Go find a scale. All right. So for the non-digital scales, ladies and gentlemen, you're going to take your rod. Well, before I get that far, if we're looking at the CER, claim evidence reasoning, this is going to be a grade for you guys today, and the homework is going to be coming to you shortly. Your claim, my unknown metal is, if we look down in the evidence section, we will see the density of aluminum, silver, zinc, tin, copper, or platinum. You have either aluminum, silver, zinc, tin, copper, or platinum. I want you to make an estimated guess which one you think you have. That's going to be your claim. Your evidence is going to be figuring out the density of said material, because everything has its own unique density. Every element has its unique density. We're going to figure that out by calculating, getting the mass and the volume, and doing some simple math. Once you have chosen which one you think your metal rod is, I'd like for you to put it on the scale. Now, when you do so, you might notice something. It now moves up. Now we get to do the sliding of the scale. I would always start with the heaviest item first. If I go from 0 to 100 and my thing immediately goes down, guess what I'm going to do? I'm going to set that back to 0. And I'm going to use the next smaller one. And I'm going to take my way through until I find one that works. Once I've gone too far, I put it back to the previous one. And I use the next scale. I'm going to figure out, I'm going to read my scale. Now, for these back here, you guys are pretty simple, pretty easy. It tells you what the measurement is. Look at that. The greatness of modern science. Did you guys hear this over?
Wait, how do you
They don't have the scale.
I don't. All right, gentlemen, why don't you start over here? I'm going to share this scale real fast. And it's right down here, sir. Aluminum, silver, zinc, tin, copper, and platinum. All right, so that one's still too far, right? So the one, so I know how much I'm talking about. Maybe one down, right? But do you think it's silver? Do you think it's zinc? So how much? Down, right? You go, so that's what's out. You think it's silver? All right. Okay. So that's not quite there. Well, you can't go wrong. You got to he's in one up, right? And then one up, yeah. So now we use this one.
Oh, yeah, let's see.
All right, and then you're gonna record. All right, okay, so for those who have the regular sliding scale, once you have identified your known values, make sure you add your unknown value. So those who had the scales over here, that had the digital scales, you got known values, right? Did you record your unknown value? That's gonna go in mass and sample.
Remember you showed up,
They still need to figure out now. There's 6 of them. Aluminum, silver, zinc, tin, copper, platinum. Pick one. This is rocket surgery, space science. Use always a digit past what you're given. All right, jump. Okay. All right, so once you do yourself, so that. All right, so I know you guys are still working on maths. Is anyone still working on maths? No? Perfect. All right. So,
Smaller side of it, smaller up there. You guys gonna need this one. What size is your rock, guys? Where's your rock picture? Probably down.
all right.
All right, guys.
Everybody else might get one of these smaller ones. So small one for you. Small one for you guys. Small one for you guys. Oh, you already have one. Small one for you guys. Small one for you guys. And then we have one over here for you ladies.
No problem.
All right, guys. Everyone that graduated cylinder?
There you go, you can use that.
So, the reason why we call these graduate cylinders is because the base kind of looks like a graduation cap that you guys would get at the end of your senior year. Now, we are going to calculate volume, one of the easiest and oldest ways to do it. Water displacement. So, on your CER, it says you need to read two items. You need to put water into your graduate cylinder, read the line, write your known and your estimate digit, and then we're going to do the next step. So, you're going to find a sink. There are plenty of sinks around. You want to fill your graduate cylinder up. I'd say go about halfway. Find a water station. Fill up your graduate cylinder about halfway. Don't fill all the way to the top. Halfway. These things are water. The things over there next to Alexis, that's a water station. The one over there next to Hazel, a water station. All these stations put out water. You want to find a station that has water. You want to turn on clockwise, counterclockwise, turn on water. Sir, halfway. Don't pour it all out, man. Come on, man. I assume y'all know how to turn water on. Oh, please tell me y'all know how to turn a spigot on now.
We did it.
Oh my God.
Oh no.
Everybody has different times.
I did it.
That's just for us. We have
No. Do not just drop it in there. All right. So, where's my little container at? All right. Okay. Everyone has put in the water in their container, yes? I need you to read. Write down the known digit. Write down your estimate digit for this. Where did I put my? Oh, here we go. Once you have done that, you've recorded that number on your piece of paper. It's imperative that you write it on your piece of paper. Then, gang, we recorded it. Wilson, we got the numbers written down.
Is it 20 and 30?
So, the lower.
I'm so
All right. So,
Once you record it, your graduate cylinder with just the water in it. This is very important because you can break my stuff. You just drop it straight down. You are going to, watch this guys, it's a crazy idea. Tilt your graduate cylinder. Perfectly around a 45-degree angle. I'm going to take said metal rod. I'm going to gently place the mouth of my container, and I'm going to let it slide in. I should see the water level change. I will now record what the water, what that change is. So if I was at 20, I slide my metal in. It's now at 21.5. 21.5. I'm going to write that on my piece of paper. Whatever the volume is right now, write on your piece of paper. Once you are done with that, I'd like you to return to your seat. Give me a second, gentlemen. We're going to ladies first.
Yeah.
Is this your? We may want to figure that part one out later. Joe.
So like, it was, when I asked them to speak,
50 was the, I can clearly read from it. I need to add this, right? So here's my reading chart.
like one, you like, last year I didn't, I did it.
All right, once you guys got your numbers, I want you back to your seats because you're gonna need your calculators for this. And your computers. I'm a computer. Hey, whose is this one right here? Ronald, you want to come over here and sit with your partner? We're not done with our partners yet, ladies and gentlemen. We're not done with our partners because we've written down the information.
Do we still need the thing?
You're going to take everything with you. Never leave any part of your experiment behind. I don't know. I'll just back to that part I can't give you. All right. So now that we have weighed out our material, I take my CER. Give me a quick second here. Oh, that takes one time. So up to this point, you should have chosen by unknown one of these 6 metals: aluminum, silver, zinc, tin, copper, platinum. Now, you're choosing this metal based off, I'm only giving you six types of metals to pick from. And also, there's 118 elements up there. It'd be pretty ridiculous. And most of them are metals. It'd be pretty ridiculous if I just gave you all 90 some odd metals to choose from. I give you 6. So up here, you'll pick
just by the look of the metal, which one do you think it is? Now, you recorded the mass of your rod. Now, if you use the digital ones in the back, maybe you got like 10.5. If you did, you want to add in your estimated digit. Because we can't see where it is, we're just going to say it's 0. If I had the scale system, and I had 0 for the hundredths, I had a 9 for the single one, and then maybe I had like a 0.5 for the third one, I'd record that as 9.5. Those are my known digits, right? I still need to add an estimate, which would be my 0. Always have the known and your unknown. Now, for calculating the volume, I told you to fill up your graduated cylinder up to about halfway up. Let's say it's 50. The meniscus was sitting on the tick line for 50. That'd be 50 is my known, 0.0 as my estimated digit. I tilted my graduated cylinder, slipped my rod in. What happened? The water gets displaced. Now the reading is higher. Now it's 56. It was on the 56 mark, and it's halfway between 6 and 7. So I record that as 56.5. Now we are in the calculation section of our work. Volume of sample equals the volume of water in sample minus the volume of just the water without the sample. We're going to be using this to answer tonight's homework. So you're going to be walking away with this piece of paper. You get points for just being here. It's crazy. So, if I'm looking back up here, volume of water in sample is 56.5 minus volume of just the water by itself without sample, which was 50.0. I can pull out a calculator if I need to, but I should be able to do that math at 6.5 milliliters. Then we're going to determine the density of your unknown sample. And here is my equation for it. Density equals the mass of the sample divided by the volume of the sample. So, the mass of my sample, I wrote that out in mass of sample line. So I'm going to use, we'll say it's a 10.5. 10.50 divided by the volume of the sample. I determined that to be 6.5 milliliters. Grams. I'm going to divide this, and I'm going to round to 2 decimal places. That's going to give you the density of your sample. Well, she ain't got one? Man, Hazel, you mighty popular today. Do me a favor. Take it out the bag and put it on the wall. Next time it goes to the office. Bag and all. Ladies and gentlemen, I don't want to play games about this stuff, but I will play that game. Now, I've got my density of my sample. I need to compare my density of sample to my known density of my different metals I could choose from. This one, guys, you're going to need your computer for.
throw this up here. I'm gonna click on Schoology. Now the cool thing is, guys, I've actually put this link here in Schoology for you, so it's easy access. In the 1G section, you're gonna go to. You need only one person uses their computer because you guys can both record this information. You go to Unit 1. You're gonna click on the LAQ that we're working on. How do we collect and report data with appropriate precision? And I'm going to color code the folder that we're using is always going to be red. So August 14th, we're going to click on that one. And you will see P table link. You want to click on a little box here because you want to go to this website. Now, we are going to have to find the 6 different elements on our periodic table. One of them is aluminum. Now, aluminum is pretty easy. Aluminum right here. Al number 13. I'm going to click on it so it stays the same. I'm going to scroll down here until I find density. Now, the density that's currently recorded is 2,700 kilograms per meter cubed. That's way too big for what we did, and we have not done dimensional analysis. We can't convert our mass of milliliters to kilograms per meter cubed. You're going to click the little arrow button here, and you're going to select grams divided by centimeters cubed. So I see here it reads density of aluminum in grams per centimeter cubed is 2.7. So on my accepted values, I'm going to say the density of aluminum is 2.7. I'm then going to go find silver. I'm going to go find all the other ones. Silver's AG if you've never experienced silver. Zinc, ZN, and I'll let you find the other three of tin, copper, and platinum. You are going to record their density. One second, please. After that, based off the densities that you've recorded, the known values, you're going to tell me which metal your unknown sample was closest to. You're going to write the element's name and its symbol. And lastly, you're going to calculate, give me a second, Herson, the percent error of what you did. You're going to take your density and compare it to the known density. Before Herson walks out the door and I stop recording, your homework. Density calculation worksheet. There are 6 questions in total where you are presented the same situation. I give you the scale. I give you the displacement of volume. You're going to have to calculate displacement of volume. You're going to have to be able to read your scale. 6 questions. You're going to have this done for me. Next class, because we only got 7-ish minutes left. You have 7 questions you're going to do. You're going to finish this part up. You're going to tell me which element you were using. You're going to tell me what the symbol of that element is, and then you're going to give me the percent error of your density. Right there. Your density to chosen metal. Does anyone understand the assignment?
Mr. Weissman,
Sir,
I interview you.
you bring it to me next time.
I'm finished.
Bring it to me next time. Because I'll lose it. You won't get credit for it. Does everyone understand the 7 questions they gotta do tonight? Alright?